All right, today we're going to talk about the infinite geometric series. So we're going to talk about being able to find the sum of a series of numbers. We talked about geometric being that it has the common ratio, and it seems kind of different. We can find a sum that is infinite, but there's going to be certain rules that have to apply in order for us to be able to find the sum of the series, and it's going to be approaching, or if in an infinite series the sum approaches some limit, as that becomes very large, that limit is defined to be the sum. So it's going to be converging onto a specific number, similar to, won't actually approach that number, but as we go on and on forever, it will converge onto that specific number. And the only way that that actually works is if the sum has a ratio, the absolute value, doesn't matter if it's positive or negative, but if that ratio, absolute value of it, is less than 1. That is the one rule that we have to check for in order to be able to find the infinite series. Because if it's higher than 1, in yesterday's notes we talked about where there was a ratio of 2. So if we went from 1 to 2, 4, 8, 16, etc., those numbers aren't converging onto any specific number, so they're continuing to get larger and larger, and we cannot find the sum of that specific sequence of numbers. But we're going to talk about which one of these would be able to have sums based off of our rule. The absolute value of the ratio is less than 1. So if we look at the first one here, what is the ratio as we go from 1 to negative 1/3, and then we're adding 1/9, and we're adding negative 1/27. We look, the denominators are being multiplied by 3, the numerators are staying the same. The ratio is 1/3, but we also have the signs changing throughout, so it is negative 1/3. And the absolute value of negative 1/3 would be 1/3, which is less than 1. Therefore, yes, this one would have a sum as it went on forever. In the second example, we have the ratio going from 5 to negative 30, and then negative 30 to 180. We have a ratio of negative 6. The absolute value of negative 6 is 6, therefore the ratio is greater than 1, the absolute value, therefore it does not have the sum. And as we look at the last one, we again see that the denominators are the only numbers changing, and they are being multiplied by 5 every time, therefore our ratio is 1/5, which is less than 1, therefore it does have a sum. So that's the first part, is being able to check it. Once we are able to check this, if it has a sum, then all we have to do is plug it into the formula here. We need the first term and then divide it by 1 minus the ratio. And that is all we have to do in order to find the sum of the infinite geometric series, assuming that it has one. So we first have to find the ratio, determine if it has a sum, and then plug it in. So in this particular case, our first term is 2. And then let's check to see if we have we can find the sum because of the ratio. So going from 2 to 1/2, 2 over 1, and then 1/2 to 1/8, and 1/8 to 1/32, we should be able to tell that the ratio is 1/4, which is less than 1, therefore it does have a sum. And looking at our formula, so the sum is the first term of 2, all divided by 1 minus 1/4. And then when we plug that in, we find out that the sum is converging to 8/3. And then the next one, 4 to negative 1, 1 to 1/4. You see the signs are changing, so our ratio is going to have to be negative. And again, we can see that we go from 4 to 16, it's 4 on the bottom, and A fourth of 4 is 1, so our ratio is negative 1/4. Plug it in. Our first term is 4 over 1 minus negative 1/4. We find out that our sum is approaching, converging to 3.2. And that is concluding the notes for the infinite geometric series.